Good afternoon. Myself, Dr. M. Takle, working as Associate Professor in Mechanical Engineering Department, Sharad Institute of Technology, College of Engineering. Today, I am here to deliver lecture on Introduction to PLC. That is basic related to PLC. PLC is nothing but programmable and logical control. Now we know in the general mechatronic system, in the center there is a mechanical system. To the right side there is a actuator, and left side there is a sensor, and below that there is a control system. In a control system, that microcontroller comes, microprocessor comes, and one of the important controller is a PLC. And PLC is nothing but programmable and logic controller. Now input from for to the mechanical system, input comes from sensor to the controller, and from sensor controller to the actuator, and through that actuation mechanical system works. By taking one example, consider hydraulic system in which hydraulic cylinder is there, and that movement of hydraulic cylinder, if you want a movement of hydraulic cylinder, that is actuation of hydraulic cylinder, then hydraulic system is built, and that total system is called as a mechanical system, and feedback to the controller is through sensor. If we place two sensors to the actuator for the forward movement as well as for backward movement, and that actuation to the forward and backward is taken place through actuator, that is solenoid valve. Considering the system, and we are placing one PLC to the system for output to the solenoid valve. When the actuation of cylinder takes place, then piston rod sent by that sensor, and that input given to the controller, that is PLC. PLC is one of the controller, and PLC operates or gives supply to the actuator, and here actuator is nothing but our solenoid valve. When input from PLC comes to the input from sensor come to the PLC, then output goes to the actuator, and that's through ladder logic this all operations are covers. So simply we say that in a mechatronic system, PLC stands in a controller form which act as a programmable and logic controller which control the total mechanical system. Here we will start with PLC. The first point is, what is a PLC? A programmable logic controller, that is PLC, is a digital industrial computer used for automation electromechanical process such as control of machinery on factory assembly lines, amusement rides, or light fixtures. PLCs are rugged, modular, and adaptable, making them popular in a wide range of applications. I already told that PLC is a programmable logic controller. It is nothing but a simply industrial computer which is used to control various mechanical systems. And already told one of the mechanical system is actuation of that hydraulic cylinder. When we are using that hydraulic fixtures, PLC plays major roles. Through PLC we can control the cylinders of that hydraulic system, and other applications of PLC as control of machinery on factory assembly lines. In a factory assembly lines are there in which machineries are there, and this machinery in a factory assembly lines controlled through PLC, because input from some and output to some, and that total controlling takes place through PLC only. So PLC is a digital industrial computer used for that various applications, including that factory assembly lines, as well as in a case of that fixtures. History of PLC. Here we study what is the history of PLC. PLC were first developed in 1960s by Dick Murray of Allen Bradley. Allen Bradley is the company who manufactures PLCs. So that Dick Morley of that Allen Bradley company first developed that PLC in 1960s. Morley was looking for a way to replace the complex and unreliable relay system that were then used to control industrial processes. Before that PLC, relay logic was used, that is, we normally say that contactors and relay logics. In right now in most of that hydraulic fixtures, which is on a VMC machines, presently they are also using that relay logics, and by using that relay logics, the system becomes hard wiring system. There are too much wirings are there required before that PLC. Morley was looking for a way to replace that complex and unreliable relay system. The system becomes complex, too much wiring is there, hard wiring is there, and that Morley of that Allen Bradley wants to replace that complex system, that complex relay system, by using some other control industrial processes. Morley was looking for a way to replace the complex and unreliable relay systems that they used to control industrial processes. PLC were an immediate success, and they quickly become the industrial standard for industrial automation. By using that PLCs, the relay logic is become absolute and the hard wiring also reduced, and it gives a quickly response, so it is mostly used in the industrial automations. So before that PLC development, relay logic and contactor logic is used, but by using that PLC, that relay and contactor logic become absolute, and as a controller PLC commonly used. So too much wiring is reduced because of that PLC, use of PLC in industrial automation. This is the one of the photo of Mitsubishi Electric PLC, in which it shows that input on the top side as well as output on the bottom side. Normally it is a Apex 5U32M. I will explain what is that. 32 stands for input plus output, means this PLC having total 16 inputs and 16 outputs. As shown in the inputs, there is a numbering 0, 1, 2, 3, 4, 5, 6, 7 and then 10, 11. There is no number 8, 9 because it depends on the bit, that is digital bit. It works on the bit, binary bit, and we know 1 bit is equal to 8 bit is equal to 1 byte. So according to that, numbering is given from 0 to 7, that is total 8 numbers are there, and from 10 to 17 again there is a total 8 numbers are there. Similar to output, there is a number from 0 to 7, that is 0, 1, 2, 3, 4, 5, 6, 7, and again 10 to 17. Same 8 bit is equal to 1 byte. According to that, the numbers are given 0 to 7 and then from 10 to 17. In upper side, we are looking that connections are there for wires, input as well as output. The input wire is connected to the PLC and output wire goes to the system. Considering the example of that again hydraulic system, the input to the PLC is a sensor and output from PLC is actuator. Actuator is nothing but our solenoid valve. As solenoid valve operates, the system operates, that is hydraulic cylinder operates. When input come from sensor into the PLC, suppose connection number 0, input come from sensor to the connection number 0, then through ladder logic output goes, suppose my output is a 0 and this is to solenoid wall number 1. When one sensor sends an input comes to this PLC to 0, then output from 0 goes to the actuator and there is a movement of cylinder takes place. So PLC plays a major role and that contactor relay logic is totally eliminated and too much wiring is also eliminated. This is the one of the example of control panel in which PLC is placed. This is the portion of PLC and this is a laptop on which relay logic is there, and we can dump through wiring, that USB wiring or any other depends on that PLC. You can dump our ladder logic into the PLC, and this is a control panel in which relays are there, SMPS there and other devices contactors are there. And this is shown that inputs and out, it is a nothing but modular is there, that input output is increased. This is the wiring for inputs and this is the wiring for output. Input from sensors comes to here and output to actuator goes from here, and this is the example of that Siemens PLC. PLC is typically made up of the following components. Considering the construction of PLC, there are following important components of PLC. We will see these components one by one. First, central processing unit, that is CPU. The CPU is the brain of the PLC. It is responsible for executing the user's program which is stored in the memory. CPU, that is processor, is the brain of that PLC, and that program is executed in the CPU only and which is stored in the memory. The CPU is having memory and which is stored in the memory. Then input and output modules. I already told that to the PLC some input and output modules are there. Some input connection, that is input from sensors, and some output, that is output from actuator, output to the actuator. Input output modules allow the PLC to communicate with the outside world, that is from sensor to the input and from output from PLC to the actuator. That sensor and actuator comes to the outside world and that communication takes place to the IOs only, that is input and output modules. Input modules receive signal from sensor and switches, while output modules send signal to the actuator and other devices. I already told that input is from sensor or it may be switch, and outputs or signals sent to the actuator or other devices, that is our solenoid wall. And third one is a PLC supply, power supply. The power supply provides power to the PLC and its components. Normally power supply to the PLC is 24 volts. PLC works on the 24 volts. Ladder logic. As we know, in a microcontroller, embedded C language is used. In a microprocessor, any language is used like Java, C, C++ or Python. Coming to the PLC, there is also some 3-4 languages are used to build logic, but normally in industrial application or industrial automation, ladder logic is the language prepared in a PLC. Ladder logic is a graphical programming language that is commonly used to the program PLC. This ladder logic is normally used or commonly used in a PLC, and it is nothing but graphical programming language in the form of graphs or in form of logic, that is normally open, normally closed, like that. This ladder logic of PLC is built. Ladder logic diagrams are made up of rungs. Rungs means steps. It made by step. That normally ladder logic or PLC run from left to right and from top to bottom. When previous slide, this is the ladder logic. The ladder logic is there. and it is rungs are there, first rung, second rung. It reads from left to right and from top to bottom. Ladder logic diagram are made up of rungs which present the steps in a control sequence. That is, sequence of control is from left to right, from top to bottom. Each rung has two or more contacts, which represent the condition that must be met for the rung to be activated. If all of these contacts on a rung are activated, then the coil on the rung is energized. The coil then sends a signal to output module which controls an actuator or other device. Means that if the contact of rung, that is, suppose if the NO contactor is there, and when we press it becomes NC, then signal comes that rung is energized, means signal goes to that rungs and that output goes to our output controller, that is actuator in that present rung. PLC applications. PLCs are used in a wide variety of applications which includes manufacturing. PLC are used to control machinery on factory assembly lines. Normally PLCs are used in special purpose machines when we are doing that manufacturing of the component, or if the assembly of the component is there, PLCs are used as a controller. Process control. PLCs are used to control process such as chemical reaction and wastewater treatment. PLCs are used in that process control also. It is used in building automation. PLC are used to control HVAC, that is heating, ventilation and air conditioning systems, lighting and security system. Then transportation. PLCs are used to control traffic signals, train system and aircraft system. The traffic signal, that is red light, green light, yellow light, and the timing is controlled through the PLC, because PLC doesn't require any timer hardware. In the logic system we can build the timer, through that the traffic signal controls is controlled. Advantages of PLC. Here we will study what are the various advantages of PLC. PLC has several advantages over other types of industrial control systems. Includes flexibility. In like microcontroller, we will put only one program in that, but in the PLC we can easily change the program, that is it can be reprogrammed. If you want to switch that one application to second application, the same PLC can be used or reprogrammed. PLC can be easily reprogrammed to change the control sequence. Reliability. PLCs are very reliable and can withstand harsh industrial environment. These products are very reliable and this can be withstand in industrial environments. That is, in industrial room temperatures, this PLC can be worked easily. Modularity. PLC can be easily expanded to add additional I/O modules and other components. Suppose I design a system and I have taken a PLC, but after that my system is expanded and I require more IOs, then I didn't require to purchase another PLC. I can, using by this PLC, I can expand that IOs. IO means input output modules, and through that IO modules I can easily program or expand the system. Cost effectiveness. PLCs are relatively inexpensive, especially when compared to other types of industrial control systems. Considering that other systems, control systems, PLCs are inexpensive. Normally we are getting in a low cost that PLC compared to other industrial control system or industrial various electronics cars. PLCs having some disadvantages also there. First disadvantages is PLC also have some disadvantages, include complexity. Sometimes it becomes somewhat difficult to program that ladder logic and that troubleshoot, that is maintenance of the PLC. PLC can be complex to program and troubleshoot. PLCs are vulnerable to cyber attack. There may be possibility of cyber attack of PLC. So sometimes we will lose our data Lack of standardization. There is no single standard for PLC programming language and communication protocols. There are n number of protocols like Ethernet, Modbus, RS-285, RS-432. There are large number of communication protocols and there is no any single standard for PLC programming language and communication between that hardware to hardware. Here the last point is conclusion. Conclusion of that PLC are a powerful and versatile tool for industrial automation. They are used in a wide variety of applications and obtain many advantages over other types of industrial control system. Normally PLC are used mostly in various industrial automation and versatile mostly, and it is a powerful tool. Some branded companies manufacturing their PLCs, so it is a big powerful tool for industrial automation and they are used in a wide variety of applications. Wide variety of application we already seen that in water treatment plant, building automation, industrial automation, manufacturing sector we are using this and it having many advantages over the other types of industrial control system. Thank you.